So I'll talk about the propeller. Have you seen a propeller closely?
Mm-hmm.
I have a big propeller. Look at this propeller. Okay, you see it's twisted.
Right.
Okay, the propeller usually rotates from like clockwise. So for me, I'm sitting in the cockpit, it's rotating clockwise. You look at this blade. So when let me talk about a few terms here. When you just start your engine and the propeller is rotating like this. You're not pushing, or you're on the ramp, you're steady and the propeller is rotating. You see the propeller is just like wing, and you see this this blade is going down, this blade is going up. So I take a sheet of paper, something. So when I see this is a wing, okay, and this is going down. Sorry. This is a wing, this is going down, this is the wing, this is going up. So when it's going down, the motion is this way, the flight path. Remember, the path is this way. So for the right, the downgoing wing, the relative air is coming from down. And you see that blade, there's an angle between this relative wing coming up and the blade going down. You see that angle?
Yeah.
That is your angle of attack of a propeller. So for the upgoing wing, because it's going up, the relative going is coming from upwards, and you see there's an angle. That is called also the angle of attack of the upgoing propeller. So when you're on the steady, you're not moving. This is how the relative wing is coming from down and up here. But when you're moving forward, the relative wing starts coming little bit at an angle when you start accelerating on the ground. The problem starts when you pull back the propeller. So when you're just steady, it's rotating, so it's creating equal thrust on this propeller. It's also blade and also creating equal thrust on left propeller. In a straight and level flight, it's fine. But the problem happens when you pull back, when you pitch back in the takeoff or climb. So what happens is, now I want you to look carefully. This is your angle. You see this is angle, and when you have this relative angle, now what happens is when you pull back, look at Dylan. When you pitch back, the angle of attack increased, right? Mm-hmm. So this one, the angle of attack is more angle of attack. And look what happened here. This is straight. And when you pull back, see Dylan? This is straight, you pull back, the angle of attack is less. So what happened now, the downgoing propeller has a bigger bite of air than the upgoing propeller. So this right side creates more thrust than the left side. This is a valuable teaching. I didn't know for 10 years. But this one is creating big bite that will yaw your airplane to the left because, so in air, it's kind of have this left turning tendency. So this is your P factor. So there are another tendency. So one is your P factor, the left turning tendencies, or just turning tendency, because we have one right turning tendency. P factor is because of the propeller blade angle when you pitch up. Then another thing, one is very simple. See, you have this big propeller going right side. What is the Newton's third law of motion again?
Every action has an equal and opposite reaction.
Awesome. So something is going right at so fast, 2,500 rotations per minute. What's going to happen? You join on the hub with the airplane. The airplane, this is very tiny propeller, but this is going right. The airplane wants to twist to the left. That is called torque. Every action has equal and opposite reaction. The Newton's law is torque. So airplane wants to go to the left. When you are flying, usually, but when you are on the takeoff roll on the ground, when you have that full power, you're still on the ground, the airplane cannot roll to the left, but it's put a lot of pressure on your left tire. That's why you're going to skid to the left when you put the full propeller, because it's moving faster. So that's how also you need some right rudder to correct that. So one is your P factor, second is your torque. Third one, what happens is, again, you have this huge propeller in front of you moving that area like in the clockwise or like a screw shape thrusting ahead. So that spiral, what the air is throwing back, it goes in that angle like around and up and hit from the left side of this tail. When it hit at the left side of the tail, it's going to push the tail to the right and push the nose to the left again. So that's spiraling slipstream. Does that make sense? Another is called precision. Precision is something, we have like gyroscopic precision. So what happened, gyroscope is something which is spinning so fast. So propeller is also spinning so fast, okay? So what happened, just to keep it simple, when the propeller is pushing so fast, and you look at this propeller now, if you want to push back, like when you pull back on like climb, this propeller goes up, but it's spinning so fast that force is felt to the 90-degree ahead of the rotation. So when you pull back, before even it fell, it's actually traveled to the right. So instead of going up, it's going to go right. So we have all these three left turning position effects, but the only right turning tendency is gyroscopic, and Carrie is going to ask you, gyroscopic precision. Probably, I'm not sure. I'm not him, but he might ask you. Any DP will ask you. So that is only to the only right turn. But we have this powerful left turning tendencies that the right side tendency is going to get. I mean, just it's not going to get noticed. But if I don't know if you've flown tailwind anytime. So tailwind is actually. It's sitting on the tailwind, and when we accelerate on the runway to take off, because we have already angle of attack, we have to reduce the angle of attack when you put full power. So when you push back, so now you push back this propeller down, but in order to, when it's rotating, before it's fell, it's actually fell to the left. Push back, fell to the left. So you're going to have left turning tendency only in tailwind. So in the tailwind we need right rudder, but here actually we don't even need right rudder because it's overcome by the other one. So what is the most thing you're doing? What is the longest time you're spending in the airplane? Is it in cruise, climb, or descent?
Cruise.
In the cruise. So what happens? This torque and spiraling slipstream are covered by manufacturer. So you know, at the bottom of this rudder, you will see that little trim which you can adjust from the hand. Don't touch it, and never touch it. Only the maintenance guy will touch it. So that is actually there to cover your in cruise torque effect and spiraling slipstream. So they don't correct for the pitch, the propeller P factor. So only you need more right rudder when you're climbing, not when you're descending. Okay. So that's why in cruise it will be so tiring to press right rudder because of torque. So they already had the little trim which fixed that rudder for you, but in the climb you need that right rudder when you have full power and all that. So since this is a little bit extra, but Carrie might ask you or your DP might ask you is, so now you're corrected for this one, right? What happened? You decelerate. You corrected for torque and all that, right? You have that little trim. So when you decelerate, instead of going left, now it wants to go right. So that time when you decelerate, you may need a little bit of left rudder to overcome what you fixed by manufacturer.
Okay.
Okay, does that make sense? Fine. Okay, you ready now?